Backgating is a powerful and often revealing technique whereby the entire dataset or gated population is shown on a two-dimensional plot in one color, and populations of interest are shown in another color. Why would you use backgating? By displaying both the ungated and gated populations in the same plot, subtle relationships between the populations are more easily observed. Backgating can also be accomplished with images where one or multiple gated populations on a 2D plot or histogram can be displayed as pseudo-colored events on the raw image. Backgating from populations on a plot to an image can then be used to ascertain spatial information associated with the population of interest. To better understand the concept of backgating, let's look at some data in FCS Express. In the current layout, we've created gates on the viable lymphs, lymphocytes, myeloid, debris, and CD45 dim populations. On the top row of graphs, you can see that in our CD45 versus side scatter plot, we've created our viable lymphocytes gate, and the events that fall within that gate are represented as orange-colored events. In the subsequent plots of propyrdine iodide versus CD45 and side scatter versus forward scatter, we have backgated the events in orange that fall within the viable lymphocytes gated population onto these subsequent plots, so we can view where the viable lymphocytes populations fall as a subset of the entire population. As the gate is adjusted, you'll notice that the backgating updates immediately. In FCS Express, multiple populations can be backgated simultaneously, as seen when we look at our lymphocytes, myeloid, CD45 dim, and debris gate set on our CD45 versus side scatter plot. When we look at subsequent plots for different parameters, you notice the colored events that are representative of the original gates that they were created from. As we adjust one or any of the gates, the backgated populations update in real time and reveal the discrepancies between different parameters and where these gated populations fall. The same concepts that apply to backgating flow cytometry data may also be used with image cytometry data. You notice we've created a green gate and a red gate directly on an image, and in the two-dimensional plot below, there's cells and events represented as green, red, and black dots. The cells that fall within the green gate are backgated onto the two-dimensional plot as represented as green dots, and the cells that fall within the red gate are backgated onto the two-dimensional plot as red dots. Again, you'll notice that these update in real time. Conversely, when we create a gate on a two-dimensional plot, the cells that fall within that plot may be represented on the image as pseudo-colored cells within the image. You notice as I adjust this blue gate that the blue cells on the image update in real time to reveal the spatial information on the image associated with the two-dimensional gate on the particular two-dimensional plot. Thirdly, in this layout we've created a data grid in which individual cells are represented. The gate within which the cells fall is represented as a colored rectangle box of that gate in the gates column, hence backgating individual single-cell images within the layout. As we adjust the gate, you'll notice that the individual cell cutout backgating is updating in real time as well. Backgating may also be used to examine spatial information on images that represent tissue sections or otherwise represent spatially distributed images. As we adjust our DAPI high gate, you notice on the image the cells that fall within that gate are updating on the image, thus giving us the spatial information associated with the cells that fall within this particular phenotype of interest. This also goes when we move our DAPI low gate, and the cells that fall within the orange gate 1 on the image are again represented by the orange dots on the two-dimensional plot, and as we adjust this gate, our backgating will update in real time. So how do we create backgating within FCS Express 5? To show you how this works, let's come back to our flow cytometry data and create a new page in the layout. We'll also bring up our data list and choose a data file to do some backgating with. We'll drag our file into the layout and drop it, and choose to insert a dot plot and a color dot plot so you can see the difference between the two different plot types. You notice in our dot plot that the cells are just represented as black dots, and in our color dot plot there's multiple colors associated with the gates of interest that we've created. If we insert a gate view, we can also see all of the gates and all of the gate colors that we've used. When we change the parameters on our plot, to something like CD38 versus CD45, the backgating immediately becomes more apparent, where the cells that fall within the myeloid's gate are green, the cells that fall within the lymphocyte's gate are red, and the cells that fall within the CD45 dim gate are blue. You notice that when we inserted this color dot plot, that the backgating was automatically created based on the gates that we had set up on our original CD45 versus side scatter plot. When we paste that plot onto this page and we adjust our gates, we can watch that backgating change in real time. Now you can change which gates are backgated on any plot at any time by formatting that plot. To format a plot, simply double-click on the plot to open up the Formatting tab. Choose the Color Dot Options, Display Gate Options. This is going to allow you to pick and choose which gates you'd like to view on the plot for backgating. If I choose only the gates checked below, I can pick and choose one color for just lymphocytes, two colors to represent my lymphocytes and myeloids gate, or I can even choose a third for CD45 dim. There's no limit on the number of gates that you can choose to backgate with on your particular plot of interest. You can also choose the converse of all gates by choosing all gates except those checked below. So if we choose all gates except those checked below and click preview, you notice that we're viewing the backgating for all of our gates except for the CD45 dim in this case. When we change this to our lymphocytes, we're viewing the backgating for all gates except for our lymphocytes. So there's quite a few features here to make backgating very useful and easy within FCS Express. Now, a common tip that we give to people is if you'd like to backgate multiple populations on multiple different parameters, instead of recreating your plots and backgating situation every single time, you can simply copy and paste the original plot that you've set up your backgating on, and then you can change the parameters of interest on that plot, and you'll now be viewing the backgating information associated with the new parameters of interest that you've set up. Again, you can format these plots at any time by coming in, choosing which gates you'd like to display, and simply choosing the gate that you'd like to backgate on that population. In FCS Express, we also have some interesting features that are called shade based on density and emphasis on plots. A shade based on density allows you to get a density styled plot with backgating information applied to it. What this means is if I double click on a plot, come into my color dot options, my bin dot specific options, I can click on shade based on density. When I've chosen shade based on density, you notice that the plot now exhibits a density-like characteristic with the plot, but we've included the backgating information within that density information. So as we change our lymphocytes population, you can see that the backgating is updating while retaining the density characteristics of the plot. Now we'll undo those changes, and we can look at another feature that we have called emphasis on plots. You notice that our CD45 dim population is being backgated on this plot, but it's difficult to see because there's quite few events located within that gate. If I double click on the CD45 dim gate and choose emphasize on plots, the cells that then fall within the CD45 dim gate will be highlighted as larger dots on the plot. And as I adjust my gate, that backgating information with the larger dots will also update in real time. Please see the other videos that we've created on the Novo software website regarding shading based on density and emphasis on plots to learn more. If you'd like more information about backgating or need additional help, please don't hesitate to contact us at support@denovosoftware.com.